So especially now that you're not directly in front of me, please feel free to stop me and let me know if I'm going too fast, and I won't be offended. Also, while we do notes, I like to call on people to participate. And this is for two reasons, just because, especially in this platform, I know it's hard to pay attention and stay engaged. So this is one way that hopefully you can increase your participation. And secondly, again, that same thing, I don't know what you don't know. So if I call on you to answer a question and you don't know the answer, that's totally fine. That just tells me that maybe we didn't spend enough time going over that concept and we need to slow down and work on it a little bit more. So don't be afraid of getting the wrong answer. It's just also a tool for me to see how we're doing on pacing. So just keep in mind, I will be calling on you all throughout the lesson to answer some questions as we go through our notes. Are there any questions before we get started on our notes? Okay, cool. Let me go ahead and share my screen and we'll get this party started. Okay, so before we get started on today's note, a quick introduction to the world of Algebra 2. So the way that Algebra 2 is organized is it's all based on graphs. So each unit is centered around a different type of graph or function. And so unit 1 is linear functions, which you've probably seen in Algebra 1. It's just talking about straight lines. So that's all we're focusing on in unit 1. So let's go ahead and fill out some key terms. So today we're going to be talking about parent functions and translation. So what is a parent function? Your parent function is the most basic function in a OG function. It's most basic function in a function family. The most basic function in a family. So there's a couple things we can do once we have that basic function. The first thing we can do is a translation. So a translation is going to shift a graph horizontally or vertically. So it's going to move it up or down or right and left, but it will not change its size, shape, or orientation. So a translation will shift a graph horizontally or vertically, but it does not change its size, its shape, or its orientation. And today we're only going to be focusing on translations. On the other hand, a transformation can change the position of a graph. It can change its size. It can change its shape, and it can change its orientation. So tomorrow we'll focus on transformations. Today we're only going to focus on parent functions and translations. Great question. Now, what does orientation mean? It means, is it facing up? Is it facing down? Is it facing right? Or is it facing left? So when we talk about changing its orientation, we're talking about, am I flipping the graph? All right, example 1, graph the following function, f of x equals absolute value of x. So a couple things, those 2 bars right here, that stands for absolute value. So what is absolute value? Just as a refresher from Algebra 1, absolute value is measuring the distance a number has from 0. So if you think about a number line, for example, 0's in the middle. Let's say we're talking about 5. So if I asked you what the absolute value of 5 was, you would count how many spaces away 5 is from 0. So it's 1, 2, 3, 4, 5 spaces away from 0 on a number line. So the absolute value of 5 is 5. If I asked you what the absolute value of -5 is, you're going to count how many spaces away is -5 from 0. So that's, again, 1, 2, 3, 4, 5. So the absolute value of -5 is also going to be 5. So the thing that you want to remember is that absolute value is always going to be positive, and that's because you're talking about distance, and it doesn't really make sense to go -5 spaces. So whenever we talk about distance, we're talking about positive numbers, so absolute value is always positive. Questions about absolute value? Okay, so for example 1, we're going to go ahead and fill out a table of values for f of x equals absolute value of x. I want you to plug in -2, -1, 0, 1, and 2. Sorry, there isn't really a space for 2, so just add it in at the bottom. So when you fill out a table of values, you're going to take the x value and plug it into the function. So you're going to replace the x with the -2 in this first case. Yes, Noah?
Where did you get the -2 and the -1, 0, 1, and 2?
You're going to just choose any points you want. These are going to be, these are points that I chose for you, just so that you can see what the shape is like. I think when in doubt, just choose -2, -1, 0, 1, and 2. But it doesn't. All right, great question. So the absolute value of -2, so you're going to ask yourself how many spaces away from 0 is -2? It's 2 spaces away from 0, so that means your output or your y is going to be 2. And then you're going to plug in -1, so the absolute value of -1. So you're asking yourself how many spaces away from 0 is -1? Going to be +1. Remember, your outputs always have to be positive for absolute value because you're talking about distance. Then you're going to plug in 0. So you're going to ask yourself how many spaces away from 0 is 0, which kind of sounds weird, but it's 0 spaces away. Then you're going to plug in 1. So how many spaces away from 0 is +1? It's 1 space away. And then you're going to do the absolute value of 2. Sorry, I ran out of room a little bit. How many spaces away from 2 or from 0 is 2? It's 2 spaces away. So those are all your y values. And remember, the end goal is to graph this. And so whenever you're doing a table of values, you're going to get an x and a y, and that's going to be the points that you're going to graph. So the first point, the x value is -2, the y value is +2. So that's your first ordered pair. Your second ordered pair is -1 and 1. Your third ordered pair is 0, 0. Then 1, 1. And 2, 2. Noah, to answer your question, why is absolute value in this case? Because our function has absolute value. Y is just the output, so it's basically what do you get when you plug in the x into your function. In this case, the function is absolute value, so that's why y is absolute value. All right, let's go ahead and plot these points. So we've got -2, 2 first. So remember, -2 is on the x-axis, so you're going to go left, 1, 2. And then your y is +2. So that's your first point. Then we've got -1, 1, 0, 0. Then 1, 1, so go to 1 on the x-axis, 1 on the y-axis, and 2, 2, 2. I miscounted. Let me just write that out real quick. All right, so you should see that this forms a V shape. So what you're gonna do is you're gonna take a straight edge if you have one and connect the points together. Might have to wait for this whiteout to dry to get that other part of that graph. All right, there we go, beautiful. So you should notice that this forms a V shape, and that's the classic tell for an absolute value graph. An absolute value graph will always form a V shape. So Noah, you asked earlier why I chose the points -2, -1, 0, 1, and 2. It was so that I could show that V shape. Sometimes if you don't show points on either side of that point of the V, then you might just get a straight line. You might not get that full V, so that's why I chose those points. And usually those points will work, -2, -1, 0, 1, and 2. So you should always have a V for an absolute value graph. You should always have a V for an absolute value graph. All right, so that leads us to the type of graph. This is called an absolute value graph. That's a type of graph. And that's what we call the parent function. So it's the most basic function in the absolute value family. And how do I know it's the parent function? If you go back to the original function, you'll notice there are no other numbers, it's just an x. So parent functions don't have any other numbers, it's just the x. It's the most basic, it's always your starting point. All right, domain. When you ask about domain of a graph, you're talking about how far to the left and how far to the right does my graph go? So domain always has to deal with x values. So you're asking, how far to the left does my graph go? Well, this arrow means it's going on forever and ever and ever and ever and ever. So it's going on forever in the left direction. And then if we look to the right side of the graph, this arrow means that it's going on forever and ever and ever and ever and ever in the right direction. So it can go forever in the left direction, it can go forever in the right direction. So basically the domain, you can have any x value you want and it's gonna work in this function. The way we say that in mathematical terms is all real numbers. So this symbol right here stands for real numbers. It looks kind of like an R, but with a double line. That means all real numbers. So you're saying that you can go forever in the left and forever in the right. Any questions about domain? All right, let's talk about range. So range refers to the y value. So how high does my graph go and how low does my graph go? So if we look at my graph, you'll notice that the arrows mean that it's going forever and ever and ever in the up direction. So there's no restriction on how high my graph can go. But you'll notice that the bottom of my graph is empty. There's nothing over here. So that means that the lowest point is 0. My graph can't go below 0. So that means that the range or the y values have to be greater than or equal to 0. You can't be below 0 for this particular graph. Any questions about range? All right, lastly, the vertex. The vertex refers to the point of your V. So wherever the point of the V is, that would be this point right here, which is 0, 0. So for this graph, the point is, the vertex is 0, 0.
Can you explain the range again?
Yeah, the range always deals with the y value. So you're asking how high my graph can go or how low my graph can go. So when I look at this V, you notice that the arrows mean that it can go forever in the upward direction. But you'll notice that you can't go below 0 because there's nothing in my graph there are no points that are below 0. So my range has to be greater than or equal to 0. That means that the only y values that my graph can have to be bigger than 0. Does that make more sense?
Yeah.
All right, so that's your parent function, but like I said earlier, we're not just gonna stop at the parent function, we're actually going to translate the parent function today. So that means we're gonna move it up and down, left and right. So the generic formula for absolute value functions is f of x is equal to a absolute value of x minus h plus k. So what do all those variables mean? It can be a little bit overwhelming at first, but we're gonna just focus on 2 variables today, and that's gonna be the h and the k. So the h is always inside of the absolute value. It's always gonna be next to the x inside of the absolute value, and it represents the horizontal shift. I always remember it because h and horizontal, they both start with h. And this is a part where it gets a little bit tricky and it's a little bit counterintuitive, so you have to be very conscious. This is where students make a lot of mistakes. If your h is positive, it's actually going to shift your graph to the left, which doesn't really make sense intuitively. But if this sign right here is a plus sign, that means you're shifting your graph to the left. If this sign right here is a minus sign, that means you're going to shift your graph to the right. So that's the h value. The k value is the vertical shift. The k value is the vertical shift. This one is what you would expect it to be. If this sign is a plus sign, that means you're going up. If this sign's a minus sign, it means you're going down. You can always find your vertex from just the equation. You don't necessarily have to graph the equation to know what the vertex is. The vertex is a point, so x comma y, where your x value is going to be your h value and your y value is going to be your k value. One thing to remember though, because the h value is a little bit tricky, your h is always going to be opposite. So let's say that this was a -5. When you find the vertex, it's going to switch to a +5. And we'll talk about that as we do our examples. These next 2 points we're going to focus on tomorrow, but we'll just go ahead and overview it real quick. If your a value, so the number in front of the absolute value, if it's greater than 1, then we're going to have a vertical stretch. And if it's less than 1, we're going to have a vertical stretch. I'll give you all another minute to copy stuff down, and then we'll go on to example 2. All right, example 2, graph the following function, f of x is equal to absolute value of x plus 2. So this looks very similar to example 1. The only thing that's extra is now that you have a plus 2 outside of the absolute value. So how is that going to change our graph? Well, we'll find out in just a sec. So for your x values, I want you to choose -2, -1, 0, 1, and 2 again. And then let's start by plugging in -2 first. So you're going to plug in -2 in for x. So you're going to find the absolute value of -2, which is +2. +2 plus 2 is 4.
Huh?
Okay, so anytime you have x values, you have to plug them back in, right? So you're going to plug in -2 in for x, and then add 2. So you're going to say, what is the absolute value of -2? It's +2. And then +2 plus 2 is 4. Does that answer your question?
Yeah.
Cool. Sometimes it's a little bit tricky, so feel free to pause me. All right, let's try the next one. So now we're going to plug in -1. So plug in -1 for x. So the absolute value of -1 is +1. +1 plus 2 is 3. Any questions about that? All right, I'm going to give you all 2 minutes to fill in the rest of the table. So plug in 0, then plug in 1, then plug in 2, and then I'll call on some people to share out their answers. So take 2 minutes, fill out the rest of the table. If you finish early, you can go ahead and start plotting your points. Take 1 more minute. Again, if you finish early, then go ahead and start plotting your points. All right, go ahead and fill in the table for me, Lexi.
So the table should be for the y values. It should go down 4, 3, 2, 3, 4.
4, 3, 2, 3, 4. Good. Any questions about how Lexi got those numbers? Okay, let's go ahead and plot them. We'll have just enough time to plot them before we break for today. So we're gonna, here are our points. We've got -2, 4, -1, 3, 0, 2, 1, 3, and 2, 4. So you'll notice you have a V shape again, which is absolutely what should happen, no pun intended. Absolute value is always a V-shaped graph. And we will fill in the rest tomorrow about describing the transformation and the vertex. So just go ahead and fill out the graph, and then we'll do the rest tomorrow. Are there any questions before we break for today? Anyone need more time to look at this screen before I change it? Okay.